Okay, the last section on polynomial functions is on the complex zeros of polynomial functions. So complex zeros, we've already talked about complex numbers, but the complex zeros will have an I in them. So the fundamental theorem of algebra says that every polynomial has to have at least one complex root. You may not have any real roots, but you have to have at least one complex root. The linear factorization theorem basically says that any polynomial can be factored, even if those factors are non-real factors. The conjugate pairs theorem says if ax plus bi is a 0, then ax minus bi must be a 0. So example 1 says if polynomial f has degree 5 and the coefficients are real numbers and the zeros are 2, 4i, and 3 plus I, there are two more zeros here. So what are they? You've got 2, 4i, and 3 plus I. The other two zeros are if 4i is a 0, then negative 4i has to be a 0. And if 3 plus I is a 0, then 3 minus I has to be a 0. Example 2 says find a polynomial of degree 4 whose coefficients are real numbers and that has these zeros. Well, first of all, so we've got the two ones. That just means that there's a multiplicity of 2 for those ones. And if we've got 4 plus I, then 4 minus I is also a 0. So f of x can be made like this. X minus 1, and because there's 2, squared, times x minus 4 plus I times x minus 4 minus I. So 4 plus I and 4 minus I are the zeros here, so that's why we plug in them here. Then from there, we can simplify. It's easiest to go ahead and simplify here before, or to full here before distributing. So I'm going to fold this first. This just seems to be the easiest way to go about it. So we've got x squared. Then we've got x times negative 4 minus I. So negative x times 4 minus I. Then we've got negative 4 minus I times x. So that's another negative x times 4. Oh, this times 4 plus I, excuse me. And then we have negative 4 plus I times negative 4 minus I. So we'll just write that out like this. Okay? And the first part, we can fold that. So we got x squared minus 2x plus 1. And let's combine our like terms over here and do some fulling at the end. So we've got x squared minus 4x plus xi minus 4x minus xi. And then we have 4 plus I times 4 minus I will be 16 minus I squared. Now, if you'll remember back when we did complex numbers, this I squared is -1. So, what we end up with now is, just bringing back down that first there, x squared, I'm going to combine our minus 4x's, so -8x. Then our xi's cancel out. And then down here we've got 16 minus -1. So that's plus 17. Pick this up and take it to the next page because we are not done. Now what we have to do is go through and distribute all of these. So distribute the x squared, distribute the 2x, and distribute the 1. Okay, so that'll be x squared times x squared is x to the 4th. X squared times -8x is -8x cubed. X squared times 17 is 17x squared. Then we go with 2x. 2x times x squared is -2x cubed. -2x times -8x is positive 16x squared. And -2x times 17 is -34x. And then we distribute the 1, so we just have plus x squared minus 8x plus 17. And then last, we can combine like terms. So combine our cubes. -8x minus 2. -8x cubed minus 2x cubed is -10x cubed. And then combine our squareds. So 17x squared plus 16x squared plus x squared, 1x squared, is 40x squared. And last, combine our x's. So -34x minus 8x is -42x, 17 on the left, on the end. So this is our function, which would produce the zeros 1, 4 plus I, and 4 minus I. Every polynomial function with real coefficients can be factored uniquely over the real numbers into a product of linear factors or irreducible quadratic factors. So we've already talked about that. Okay, example 3. So here is another example of finding the zeros of a polynomial function, except this time some of them are going to be complex. So, just as in the last part, we start with our P and Q. So P, 20, the factors would be plus minus 1, 2, 4, 5, 10, and 20. And for Q, the factors of 2 are positive -1, positive -2. So we write all our options. So first we put everything from P over 1. So we're just rewriting what was up with P. And then everything of p over 2. So we have plus or minus 1/2. Then there's 2 over 2, but that's 1, which we already have. Then there's 4 over 2, but that's 2, which we already had. Then plus or minus 5/2. Then 10 over 2, which is 5, we already had. And 20 over 2, which is 10, which we already had. So here are our potential real zeros. So we start to test them. Start with -1. And we plug in. And when we plug in -1, here I'll write it out the first time. We get 90. So -1 is not a 0. So we try 1. And we get -20. Therefore, 1 is not a 0. So next in our list is -2. And we get 280. -2 is not a 0. So we try 2. And that gives us -72. So 2 is not a real 0. So we go on to -4 next on our list. Gives us 1620. Nope. So we try 4. Sometimes you have to go through several of these, as you can see. We get -140. No, we're getting close, I promise. -5 gives us 3190. Nope. But 5, yay. We finally have it. Gives us 0. So that tells us that x equals 5 is a 0 of our function, and x minus 5 is, in fact, a factor of the function. Okay. So remember, next step is to divide by that factor, 5. Write out the coefficients. We're going to use synthetic division. Okay, so we get this polynomial here to be 2x, it was x to the 4th to begin with, so now x to the 3rd minus x squared plus 8x minus 4x. So far right now, we have that our function is, first, x minus 5 was a factor, and then we have this 2x cubed minus x squared plus 8x minus 4x. Now we need to find the next term. On your notes, you can actually factor this by grouping, so I did it by grouping on your notes. But just to practice a little bit more, I'm actually going to go through the normal process of starting to test zeros again. So we've tested 5. Oh no, I don't want to do that. Never mind. It'd take us all the way to 1/2. 1/2 is the next one. So yeah, you could test zeros if you want to. But let's not. Because I know that this one is going to, luckily, factor by grouping. So, group. And an x squared can come out. And a 4x can come out. Oh, I've got something off here. that should be just a 4. And that should just be an x right there. Do I have that wrong on the previous page? Yep. Sorry about that. That should just be a 4. But you probably already knew that. Okay. So pull out the 4. And we've got 2x minus 1 again. So it factors to be x squared plus 4, 2x minus 1. So at this point, we have x minus 5 times x squared plus 4 times 2x minus 1. Okay, can we factor any more? Well, we can't factor any more than this without having irrational numbers. So this is as far as we can factor without irrational numbers. So this is the factored form. When we go to find the zeros now, you'll see we take each of these and set them equal to 0. We'll move that one over there and do the 2x plus minus 1 first. Then we've got 5 and 1/2, but here we've got a negative. So to take the square root of a negative, remember, we have to use I. So we have I times the square root of 4. And the square root of 4 is plus or minus 2. So it's plus or minus 2I. So your solutions, your zeros, are 1/2, 5, negative 2I, and positive 2I. And I provided another example for you on your notes if you need to look through that, but I'm not going to record it on here. If you need it, you can look in your notes. And that concludes polynomial functions.